tea powder processing system. By Siti, Norhana, Farah, Diyana, and Hafizah. We chose to process tea powder. So why tea is chosen for this design? It is because the variety use of tea, such as 1. Food industry, 2. Medicinal, and 3. Pharmaceutical. There are 3 parts of design. 1. Hopper design. 2. Pneumatic system. 3. Fluidization process. First, let's see the hopper design. 1. It's a converging sloping wall section attached to silo. 2. Storage container used to dispense granular materials. 3. Design, easy to load and unload. 4. Conical type is used. Design of hopper, data extracted from journal. First, the values of unconfined and yield stress and compacting stress are obtained from powder flow function. This is the graph of powder flow function. Second, the given data are, the effective angle of internal friction is 40 degree, and kinematic angle wall fraction is 15 degree. From the graph, the hopper flow factor is 1.5, and semi-included angle of conical hopper wall slope is 31.3 degree, after -3 degree for safety margin. Third, the critical flow is obtained from the graph of powder flow function, and hopper flow factor, with equation below. Thus, the critical flow is 1.6. Fourth, to find conical hopper diameter, H is calculated, which is equal to 2.52. Hence the hopper diameter obtained is 0.45 meter. Fifth, to find height of hopper. Calculations are done by taking 100 cubic meters total volume of hopper and silo. Calculated capacity of silo and assuming silo diameter is 2.5 meters, and radius is 1.25 meters, the calculated values are, the capacity of silo is 91,300 kilograms. The height of hopper is 2.06 meters, and the mass flow rate is 1.057 kilograms per second. The volume of hopper is 4.09 cubic meters. Next, the height of silo is 19.5 meters, and the volume of silo is 95.91 cubic meters. All calculated using respective equation. In conclusion, these are the dimensions and values calculated in our hopper design. The hopper has an electrical vibrator attached to it to promote better flow. There is the design of the hopper, and as you can see, the electrical vibrator attached to it. That's all for hopper design. So, now, we are moving on from design of hopper with pneumatic system. Gases have been transporting particulate solids in industry via the pneumatic transport system, therefore, tea powder will be transported from hopper into the fluidized bed dryer via pneumatic pipeline system. In this part, calculations are done on finding the velocities of gas and particles, pressure drop in horizontal and vertical pipeline, and also the bends in the pipeline. This is the design of the pipeline. A blower is installed to allow the tea flow. Detailed calculations are done in order to calculate the pressure drop from the extracted info. From previous calculation, the opening diameter of the hopper is 0.45 meters. Based on American standard, the diameter of pipeline chosen is 0.45 as well. Velocities are determined. The minimum velocity to maintain the particulate flow is called the saltation velocity. Meanwhile, U0 is superficial gas velocity, which also known as operating velocity. With the mass flow rate assumed to be 1.5 meter per second, greater than the calculated value, the saltation velocity is determined using the equation. Calculated, the saltation velocity is 11.2 meters per second, and the value of operating velocity to be 16.808 meter per second, as it has times with 1.5 of safety purpose, and US to be 15.21 meters per second, to calculate the pressure across the horizontal pipeline. assuming the total length to be 20 meters. And all the initial acceleration of the solids and the gas take place in the horizontal sections. Therefore, terms 1 and 2 are required. For term 3, the fanning friction equation is used assuming that the pressure loss due to gas or wall friction is independent of the presence of solids. For term 4 useth Hinkle correlation. Terms 5 and 6 became 0 as θ is 0 for horizontal pipe. Thus, the pressure loss in the horizontal sections of the transport line is as shown. Moving on from horizontal pipeline. Now, we focus on pressure drop across the vertical pipeline. Assuming the length of vertical pipe is 5 meters. The terms involved are 3, 4, 5 and 6. Terms 1 and 2 is 0 as the initial acceleration of solids and gas is done in horizontal section. Now, the pressure at the bends of the pipe is calculated. In our pipeline, we assume to have two 90-degree bends. The pressure is calculated as equation shown. The total pressure for the pipeline system is calculated to be 0.3173 bar. The blower in industry installed has the allowable pressure until up to 0.35 bar. Therefore, the tea powder will flow inside the pipeline. The last part is the fluidization of the tea powder. In our design, the type of dryer used for the fluidization of tea is continuous fluidized bed dryer. The pressure of heated air in a fluidized bed dryer is 1 atmosphere and the temperature is 95 degrees Celsius. This value is chosen to ensure the tea powder is in a good quality. So, according to the thermodynamic property tables, the density of heated air is 0.9588 kilograms per meter cube while the viscosity of heated gas is 2.16 exponent to the power of -5 kilograms per meter second. In order to fluidize the tea powder, the superficial gas velocity must be greater than the minimum fluidization velocity. The Biens and Gell chart, 1974, is used to calculate the minimum fluidization velocity. Hence, the value obtained is 0.00245 meter per second. Thus, the value of superficial gas velocity chosen is 0.1 meter per second. Moreover, in order for the entrainment to occur, the superficial gas velocity must be greater than terminal velocity. The terminal velocity is obtained by using the equation shown. Since the value obtained is less than 73, the equations of correlation are used. And, by using Reynolds number equation, the value of terminal velocity is obtained, which is 0.01280 meter per second. So, in order to entrain the tea powder from the fluidized bed dryer, the value of 0.1 meter per second superficial gas velocity is chosen. This is design of the fluidized bed dryer where it has heated gas to dry the powder. The gas is passing upwards through a bed particles that's supported by a distributor. The overall design. As a conclusion, the upwards gas velocity which is higher than the terminal particle velocity will make the tea powder to fluidized and entrained in the dryer. Thank you for watching. Don't forget to like this video.